Okay, so question number 3. Ammonia is a weak base with a Kb value of 1.8 times 10 to the negative 5. Calculate the initial molar concentration of a solution of ammonia if the pH is 10.06. Okay, so first let's write out the reaction between ammonia and water. So the ammonia is a base, so it will accept one of the protons from water and become NH4+, which is the ammonium ion. And then our water just lost a proton, so now it becomes OH-. So now we can construct an ice table for this reaction. So we are trying to solve for Y, which is the initial molar concentration of a solution of ammonia. So I'm just going to denote this as Y, because for the change, I will denote this as X. So at equilibrium, the concentration of ammonia is Y minus X. We don't need to focus on water since it isn't really part of the reaction here. And for NH4+, it has an initial concentration of 0. And the same thing with the hydroxide ion. They both start off as 0. And for the change in concentration, going to be positive X. And now at equilibrium, their concentrations are equal to X. And we were also given the Kb of this reaction. So Kb is equal to 1.8 times 10 to the negative 5. Okay, so now let's write out an expression for Kb. So Kb is equal to the concentration of our products, so NH4+ times OH- divided by the concentration of our reactant, which was NH3, and these are all at equilibrium. So you can see that we have like a bunch of unknowns. Well, we have two unknowns. We have Y and X. But this question also gave us pH. So pH is equal to 10.06. So if we recall that POH is equal to 14 minus pH, then we can solve for the POH of this solution. So 14 minus 10.06 is equal to 3.94. And now that we have the POH, then we can actually calculate the concentration of our OH- ion, because this is the same thing as 10 to the power of negative POH. So now we just sub in our POH value, so negative 3.94, to give us a concentration of 1.148 times 10 to the negative 4 moles per liter. So let me show our KB expression if we were to sub in all of the variables. Notice that for both NH4 plus and OH minus, they're both x, so we can rewrite this as x squared. And for our denominator, concentration of NH3 at equilibrium is y minus x. But now, since we know the concentration of OH minus, this is the same thing as our x value, so we can just sub that in to our equation. So 1.148 times 10 to the negative 4 squared divided by y minus 1.148 times 10 to the negative 4. And also, I can even write in my KB as 1.8 times 10 to the negative 5. So now I only have my one unknown, which is y. So let's just try to isolate and solve for the y. And when you do the following calculation, you should end up with 8.47 times 10 to the negative 4. So therefore, the concentration of NH3, well, the initial concentration, is equal to 8.47 times 10 to the negative 4 moles per liter. Okay, so now let's see what the junior tutor said. So first they got the pOH, they got it 3.94, and then they found the concentration of OH minus, 10 to the power of negative 3.94, and they got 1.148 times 10 to the negative 4. Then they showed their ice table and the KB expression, and then subbed in all of their known values. And when they solved for y, they also got 8.47 times 10 to the negative 4. So this solution is correct.